Hello everyone, welcome to data structures tutorial. Today we are going to talk about stack as I already told. So first the important question is, what is stack? Stack is an abstract data type which is commonly used in most of the programming languages uh, for performing various real life applications. Why it is named stack? Because it behaves like a real world stack. For example, if we consider a deck of cards or a pile of plates, for example, the arrangement of chairs one after the other, right? So this is a kind of stack of chairs, stack of plates, stack of, let's say, biscuits, stack of books, right? So it is this kind of data structure. That's why we call this data structure as the stack. So a real world stack allows operations at one end only. So whatever this data structure we are going to have, that data structure allows operation at only one end. Other end is not allowed. For example, we can place or remove card or plate from top of the stack. So when we are placing plate into this particular, let's say, container, so the first place will be placed here, then second will be here, then third will be here, and fourth will be here. That means we are adding the plate from the top of the stack, on the top of the stack. And when we have to remove, in that case also we are removing it from the top end of the stack or top end of this collection, right? So stack allows all the operations at one end only. That is what I just said. At any given time we can only access top element of the stack. So when I have to remove, that means I can access this top element of the stack for removing, and when I have to insert a new element, then also I can insert the element at the top end of the stack, right? This feature makes it last in first out, that is LIFO data structure. That means a feature by which we insert the element at the top and also we remove the element from the top. That feature makes it LIFO data structure, that is last in first out. Whatever is element we are going to insert last, that is going to be out first, right? Here the element which is placed or inserted last, that is going to be accessed first, or let's say removed first. Now let's talk about the definition. A stack is a linear data structure. Why linear data structure? Because arrangement is done or accessing is done one after the other in sequential manner. So stack is a linear data structure in which insertion, which is called in technical term as push, and removal, which is called in technical term as pop, takes place at the same end of the stack. This end is called as top of the stack. The other end of the list is called as the bottom of the stack. So all the operation, that is pushing operation and popping operation, both these operation we perform on the top of the stack. That is the definition. So here you can see, assuming that initially the stack is empty and now we are pushing various elements into the stack. So as soon as we push elements into the stack, the top of the stack changes. Now you can see here, when we are performing first push operation, then the top is increased by 1, and then we are having one element A, then B, then C, and then D, and then E. When stack become full, then when we want to perform one more push operation, we can perform, because stack in that case is full. Now when we perform pop operation, that is nothing but removing element from the stack, right? So when stack is empty and we are trying to perform pop operation, it gives message as stack is empty. Is this clear? Okay, fine. Now whatever in brief I have shown operations on stack, that is what we are going to see in detail. Here stack operations involve initializing the stack, using the stack, and then de-initializing the stack. That means first we are going to declare the stack, then we are going to initialize the stack. Initializing means allocating memory to the stack, and then using it for whatever purpose we have declared it, and then de-initializing, that means deleting the stack if it is no longer required. So apart from these basic steps or operations, stack is used for the following two primary operations. These operations is push operation and pop operations. What push means? It is storing or inserting an element onto the stack. Pushing is what? Either storing or inserting an element onto the stack. And when we perform pop operation, it means that removing or accessing or deleting an element from the stack. So these two are basic operations that we perform on stack. Apart from that, when we have to, let's say, perform these push and pop operation, at that time we have to perform two more operations. When we want to perform insert, then we need to check whether stack is full. If stack is full, we are not allowed to insert a new element into the stack. That means we have to check what the status of the stack, whether stack is empty or full. So when stack is full, we are not allowed to insert. When stack is empty, we are not allowed to pop operation, or let's say remove element from the stack, because stack is already empty. All right. So these operations are, let's say, is full and is empty, these two operations. Apart from that, we also perform pico operation. That operation gives the top data element of the stack without removing it. We don't want to remove the data element, but we want to see what is at the top of the stack. In that case, we can perform peak operation. And is full is to check whether stack is full, and is empty is to check if stack is empty. So basically, three operations, that is two operations, that is push and pop, and here that we have three operations, that is peak, is full and is empty. In all, 5 operations. 2 plus 3, that is 5 operations we are going to implement in C programming language. 5 stack operations we are going to implement. Okay. Now, at all times while implementing the stack in C or in any programming language, at all time we maintain a pointer to the last pushed data on the stack. That means we have a variable which contains the value of the top of the stack. We call it as a pointer, top pointer. At this pointer always represent top of the stack. So we are giving name it as a top. We are giving name it as a top. The top pointer provides top value of the stack without actually removing it. So when we want to see the value of the top, it is going to give us the top element of the stack, right? So no need to actually removing from the stack. We can directly get the value of the top element of the stack. Now, procedure to support stack operations. The first operation that we are going to see is the peak operation. Here algorithm is like begin procedure peak, then return stack top and end procedure. So here it is written in the form of pseudocode. This code is written in the form of pseudocode, right? Pseudocode we have already seen what is meaning of the pseudocode. Okay. Now the same is converted into the C programming language. The same code is converted in C programming language. In this, the peak operation we have written as a function. Peak operation we have written as a function, and what that function is returning? It is returning stack, and we are passing it a parameter as top, or let's say index as top. So here we are declaring stack as an array, and top is going to become index, and whatever is the current value of the top, that index value we want to display, we want to access. It means that this peak operation is giving us what? Top element of the stack. It is giving us what? Top element of the stack. Is this clear? It's straightforward, right? Now is full. What is algorithm for is full? Very simple. Begin procedure is full. If top equals to max size. Now see, is full means what? Assuming that we are having size of array or size of stack as, let's say, 4. Size of stack is 4. Index, let's say, so max size is, let's say, 4, right? Now begin procedure is full if top equal to max size. So here when we will insert first element, it will be 1, then 2, then 3, and then 4. That means the top value is going to become what? 4. So when top is equal to max size, that is 4, it means what? All these slots in the stack are filled. They are not empty. That's why we will say that is full condition is true. That means my stack is full. I cannot insert new element into the stack. So everyone understood what to check to see whether stack is full or not? Is full is the function. So here if top equals max size, we will return a value as true. That means my stack is full. Else I will return false as my stack is not full. The same can be implemented in C programming language like this, where is full is for function which is returning a value of type boolean. So what is boolean value? True and false. So if top equal to max size, return true, else return false. So when the value of top is going to become, let's say 4 in this example, it is going to say 4 equal to max size, that max size is also 4, condition is true, so it will return value true. That true value will be written by this is full function, and then by checking the value written by is full, we will conclude that my stack is full. I am not allowed to insert a new element. Is this clear to everyone? Right? Fine. Now after is full, we have to check whether stack is empty or not. Now in which case we need to check stack is empty? When we are performing a pop operation. That means we are trying to remove an element from the stack, but currently my stack is empty. So when my stack is empty, I am not allowed to pop or delete element from the stack, right? So if I am trying to delete, it should give me a message as stack is empty or stack underflows. So algorithm very simple, is empty if the value of top is less than 1. If the value of the top is less than 1, then return true. Now assuming that this is my stack, currently the value of top is equal to 0 because there is no any element in my stack, right? My stack is empty, no any element. When I am inserting first element, the top value will become 1 because at 1 we have first element, right? So when the value of top is less than 1, that means it is equal to 0. I am going to return true. It means that my stack is empty. So when my stack is empty, pop operation cannot be performed, right? Now if my stack is not empty, it is going to return false. I can perform the pop operation. Is this clear? Same code can be written in C function as similar to is full, is empty, it is going to return a boolean value. So when it is going to return a true value, when top is equal to, you can write here 0, you can write here -1. So when we are writing -1, when we are implementing the stack with array. So array index starts with 0. That means at index 0 we can have one element. So when the value of top is -1, it means that my stack is empty. Because when we are going to add one element into the stack, the value of the top will be incremented by 1. So -1 plus 1 going to become 0. So at index 0, we will insert first element from in the stack. Is this clear? Is empty code, right?